Okay, so last time we started talking about descriptive statistics. Particularly, we looked at the mean, the variance, and the standard deviation. We had these 6 observations. This is a sample taken from a population. We didn't really define what that was, but it was a population. And IQ was the random variable. And we looked at how it is we go about finding the mean and the variance and the standard deviation. So this time I want to take a look at 2 more topics having to do with descriptive statistics. First of all, I want to talk about precisely what we mean by skew, and then I want to take a look at how we quantify the relationship between 2 variables, particularly the covariance and the correlation. Okay, so let's say we have given some kind of exam. And we're going to plot the scores that we saw on the exam this way. We're going to take our scores and we'll put them down here on this axis. So this will be score. And this will be the number of people who got that score. Okay. Okay, so we've got, let's say it's centered on 50, and it goes all the way up to 100 and all the way down to 0. Okay, so let's say that, so this will be 60, 70, 80, 90, so 70, and this will be 40, 30, 20, 10. Okay, so 10, and we'll say 90. Okay, so this will just be the number of people who got that score. Okay, and so let's say 1, 2, 3, 4, say 4 people got a 70. So we'll go ahead and say 1, 2, 3, 4. So we'll just say, we'll just put a bar there. Okay, 4 people got 70. Okay, and let's say 3 people got somewhere in the 80s. So we'll put another bar here for 80. And then we just had a couple people who got in the 90s. Okay. But going down this way, on the other hand, we had a few people who got somewhere in the 60s. Let's say just a couple people in the 50s. And then we had, let's say, 1 person in the 40s, 1 person in the 30s, 1 person in the 20s, and then let's say 1 person who got 10. So if we were to draw a smooth line to get a handle on the shape of this, it would look like this. Okay, so if we were to say, well, what is the mean here? And if we were to add it up, it would probably be somewhere around here. So this would be our mean, our x bar, right there somewhere. Okay. On the other hand, if we were to say, well, where is the median? That is, if we were to line all these scores up in order, we would find out that the median might be like here. Okay. So even though we have folks that are way, way out here on the left, because we have more people over here, we're going to have, if we line them all up, we'd have a middle point right around here. So that'll be our median. Okay. So what we have here is a situation where we have our mean is less than our median. Okay. And this is what is known as left skew. Okay. So if we were to, we can think about skew as being sort of the difference between the mean and the median. Okay. So let's say we have, in the case of a left skew, this would have a negative sign. So we would have a negative skew. Okay, the other situation, and I'll just sketch it up here really quickly, is, and I'll just go straight to the smooth part of it. We might have a distribution of scores that actually looks like this, where we had a kind of a lump down here low, and then we had some folks way out to the right, like this. So in this case, then, we might have a median here and a mean out here. Okay, and the reason for this is so we've got a bunch of scores that are just way out here. They're kind of outliers in X, you might call them that. And so in this case, we've got an average, a mean that is greater than the median. And when this happens, this is just called a right skew. Okay, so this is what we mean by skew. We're not going to go over how it's calculated, but basically when the median and the mean are exactly equal, so if, X bar, okay, so we have zero skew, and, that'll be symmetrical. That'll be a symmetrical, like that perfect bell curve, okay? But most of the time we're going to have a little bit of skew. In this case, if we have a left skew, it's going to be negative. If we have a right skew, it's going to be positive, okay? So if we were to come back here and take a look at the variable that we looked at last time, and we were to come back here to our data analysis tab and do our descriptive statistics. Okay, and we'll select this range again, and then do the summary statistics. You see that one of the measures that it gives us is a skewness. Okay, and in our case, it just happens to be 0. We just lucked out having a perfectly symmetrical distribution. So that being the case, so I see the mean is 110 here, so chances are the median is 110 also. Yeah, okay. So the mean and the median are exactly the same. So I can look at this and know that this is a perfectly symmetrical distribution. Okay, so that's what we mean by skew or skewness. Okay. So the second thing I want to take a look at in this video is the relationship between two variables. So last time we were just looking at a single random variable, that is IQ. So we had 6 observations of IQ in our sample, and we were able to get certain descriptive measures of that, including the mean, the variance, standard deviation, and skew. Now, so but what if we were interested in thinking about, drawing some conclusions about the relationship between IQ and, let's say, SAT score? So once again, I've got a sample here of 6 observations, so 6 people, and I've got their IQ and their SAT score. Now, this is not real data, so I don't really have any kind of insight into the real relationship between these two variables, but for demonstration purposes, I've just put some random data on here. Okay, so what can we do to try to understand, well, how are these two related? Are they related very strongly? Are they related in a positive direction? So how might we, go about doing this? Well, one thing we could do is maybe just start off with some things that we did last time. So let's go ahead and get our mean, and let's get the standard deviation. Okay, so remember that Excel doesn't have mean, you just have to do the average. So we'll do the average of these. Okay, so 110, same as last time, and then the average SAT score for this sample was 1161. Okay, and the standard deviation. So remember that we're treating this as a sample, so we're going to use STDEVS. We'll select that range, okay, and then we can just copy that over, and show us the standard deviation of the SAT score is 150. Okay, so now what we want to do is to think about, well, how do these vary around their mean? So when we were talking about the variance last time, we were wondering, just how spread out they are has to do with where these are in relation to the mean. So why don't we do that again and see if that gives us some insights to go on. Okay, so I'll go ahead and insert a column here, and I'll call this x minus x bar. Okay, so once again, I'm interested in the difference between this observation and the mean for this observation. So x minus x bar. And this will be, we're calling this variable y, so the SAT score will be y, and we'll do y minus y bar over here. Okay, so we're just going to do, okay, so what is the difference between this and the mean? Okay, and so again, we'll make that an absolute reference by putting $ in there so that we can copy. So that's no different from the mean, and that's 10 above, 10 below, 20 below, 20 above. Okay, we'll do the same thing over here. So tell me what is the difference between this and the mean down here. Okay, so that is 38 points above, 138 above, 61 below, etc., etc. Okay. Okay, so now we can start to see how these two move in relation to each other, right? So we can see that, well, this one is no different from the mean, so that doesn't tell us anything. But in this case, we have, so the IQ here in this observation is 10 points above the mean. And we can see that the SAT score is 138 points above the mean. In this case, for observation number 3, we have an IQ that is 10 points below the mean and an SAT score that is 61 points below the mean. Okay, so again, here we have an IQ that's 20 points below the mean, and we have an SAT score that is 151 points below the mean. For observation number 5, we have 20 points above the mean and 198 points above the mean. Okay, so one thing that we can observe right away is that when the IQ is above the mean, the SAT score tends to be above the mean also. And when the IQ is below the mean, the SAT score tends to be below the mean also. Okay, so let's go ahead and do something that will kind of consolidate this intuition. Let's go ahead and take the product. Let's multiply this column times this column. Okay, so we'll just call this the product column. Okay, so I'm just going to do this one times this one. Okay, this one's not very interesting because it's just a 0. Now let's see what's going on here. Okay, so notice that these all wound up being positive. Okay, so, and the reason for that is if we look at this, we had a positive number. So for observation number 2 here, we had a positive number multiplied by a positive number. Okay, so that gave us a positive, right? Positive. Okay. And in this case, we had a negative number multiplied by a negative number, which gives us a positive again. Here again, we have a negative number multiplied by a negative number. Again, negative times a negative is a positive. And then we had a positive times a positive here. So, and that, of course, is a positive. Now, if this had been positive and this had been negative, in that case, we would actually have a negative here. So, and that would have given us a negative, but as it stands, all of the numbers that we have here are positive. Okay, so this gives us something that we can go on. So now we know that these two are positively related in some way. Okay, so But now how do we gather all this? Well, maybe what we can do is, to what extent are, how strong is this relationship? Well, let's go ahead and just add these up. This isn't the complete way to do it, but this will give us a step along the way. So we add all these up. Okay, so there's 9,000. Okay. Now, it turns out that we have most of a certain statistic here called the covariance. Okay, the covariance, right? So the only step that we're missing here, and let's go ahead and take a look at the slide. Okay, so on this slide, you're given a formula here for the covariance. Okay, so the covariance describes the strength of the linear relationship between two numerical variables, x and y. So in our case, this was our IQ variable, and this was our SAT variable. Okay, and so what we found was we took the difference between the value of the variable and the mean of that variable, and then multiplied it by the difference between, for the other variable, the difference between that observation and its mean. Okay, so going back here, this was this difference, so this is x, this was x minus x bar, this was y minus y bar, and this was their product. Okay, so that's the product. This thing right here is the column that we just called product. Okay, and then we just decided, well, let's see what we can do, and we added them all up. So we put this sum right here. Okay, so we don't quite have the whole thing yet because there's one more piece of the covariance that we haven't incorporated, and that's to divide by n minus 1. Okay, so let's go back and do that. And so now we're going to take this and set it equal to this divided by, remember our n is just the number of observations, so that was 6 minus 1. Okay, so 1,800. So now we have a number, 1,800, that tells us, it gives us some measure of the strength of the linear relationship between these two. So one thing to notice is that it's positive. So that means when IQ goes up higher, SAT score tends to go up higher. When IQ goes lower, SAT score also goes lower. So it's positive, so it means they go in the same direction. Okay, positive means same direction. Okay, and so just to, so again, we calculated it manually, but what we would normally do is to use an Excel function to do that whole thing for us. Okay, and so they just give you covariance.s. Once again, we're choosing s because we're treating this as a sample. That means it's going to divide by n minus 1 as we did over here. Okay, so I need to, of course, select the ranges for both variables. Okay, so show me the covariance between the IQ, so it's colored blue here, and the SAT, and that calculates it as 1,800, which was the same answer that we got over here. Okay, so this is this gives us some information. So we know that if this number is fairly large, that the relationship is pretty strong, right? And we know that it's positive. So we can say, okay, well, they move in the same direction. The slope, if you were to put these on an axis, the slope would be positive. Okay. It is not the case that when IQ goes up, SAT score goes down. When IQ goes up, SAT score goes up. Okay. But the magnitude of this doesn't really tell us much. 1800, we know that it's large, but we don't really have an idea of how large it is. So how do we convert this into something that we can understand in terms of the that will actually give us some kind of reasonable standardized metric of how strong this is? Well, one thing that we would really like is if we had something clear that said, okay, well, what if it ranged everywhere from -1, 0, and 1. So let's say everywhere from -1 to 1, where 0 means no relationship, and -1 means strong or perfect negative relationship, and 1 is perfect positive relationship. Okay, so if we had something that fell in along this range, that would give us a much more interpretable number. Well, it turns out that this is exactly what the correlation coefficient is. Correlation coefficient gives us a number to describe the relationship between two variables, and it ranges from -1 up to 1. So, and it turns out that we can get the correlation coefficient. Write this down, correlation coefficient. Oops, correlation coefficient. Okay, turns out that we can get this by dividing this covariance by the product of the standard deviations for each of the variables. Okay, so let's do that manually first before just asking Excel to do the correlation. So we set this equal to, okay, so the covariance divided by, okay, so we have the standard deviations for each of the variables. This is the standard deviation of IQ. Then we're going to do that times the standard deviation of the SAT score. Okay, so 0.85. Okay, so what this tells us is that this is getting very close to a perfect positive relationship. Okay, so 0.85 is a pretty high correlation coefficient. It's pretty close to 1. If this had been negative 0.85, we would say that's a pretty strong negative correlation. Okay, so over here, we'll go ahead and do the shortcut way. Okay, so we'll ask Excel to give us the correlation. So it's just correl. And once again, we have to select the two ranges. So we'll select that range, do comma, and then that range. So correlation coefficient of those two variables, and it is the same. Okay. So taking a look at the slides then. So if we were to make a scatter plot of these two variables here. So this one, this range, and then this range, and go ahead and do a scatter of them, and we can just add a trend line real quick. Okay, we can see that the relationship between these two variables is, it's pretty strong. If we were to draw a line here, it does pretty well describe the relationship between these two. Okay, higher IQs tend to have higher SAT scores. Not always. We do have a point here that's not exactly on the line, but it does a pretty good job of sticking to a positive relationship. And this would explain why it's a positive 0.85 correlation coefficient. Okay, this slide here gives you sort of what a scatter plot would look like for a number of different correlation coefficients. If X and Y were perfectly negatively related, that is, if I were to say, okay, weight and your weight times -1, that would be a perfectly negative relationship, and you would have a downward sloping line like this, and so your correlation coefficient would be -1. In this case, we have a relationship that is negative, but it's not perfect. Not all of the points are exactly on that line. So it's negative 0.6. So it's pretty close. Still a pretty strong negative relationship. Okay, down here we see a perfect positive relationship. Okay, so if I were to put your weight and your on the x-axis and your weight on the y-axis, that would be a perfect positive correlation. It would be +1. Here we see a correlation coefficient of +0.3. That is, it is positive, so we got a slope up here, but there are lots of points that don't fall exactly on that. So it's not a perfect relationship, but it is a positive one. But we can see that the magnitude of this, so the absolute value, the magnitude of the absolute value, or sorry, the magnitude of the absolute value of the correlation coefficient, it's only 0.3 here. So this tells us that it's not a very strong relationship. Okay, and here we see a correlation coefficient of 0. So what's happening here is y is always the same no matter what x is. So therefore there is no relationship whatsoever between these two. Okay, all right, so those are just a couple more topics having to do with descriptive statistics. And as always, please let me know if you have any questions.